Hello, everybody. Welcome to Mankind in Training. I'm your host, Joshua Parr. Today is the C++ deep dive that I've been saying I've been going to do. Um, so, without further ado, I will share my screen. Now, this is C++.com. Move me up here. And C++.com, just like pretty much all of the other programming languages, anytime I had any trouble, if you go to the documentation, it's actually far more useful than you might think. Just have to do some reading. Now, reading isn't fun, but most of the time it will solve your problem. Rate on C++.com, spelled out like that. They have a tutorial, and it's basically got just about everything that I learned in the college course. There's not in fact there's actually things in here that they didn't have in the college course. So just know that with anything there's almost no easy way to be proficient and quick at stuff unless you're just naturally good at things or you have experience with something similar so you can do a lot of relational thinking in your head. You're like, well, that's like this. So if I do that, I don't know. It helps with analysis, I guess, but there's no quick, fast way to learn an entire programming language in like an hour or two and actually be proficient at it, even if you're following along with one of those tutorials here on YouTube. It's really difficult. You actually have to do coding yourself. You have to try. If you're not trying to code things and seeing what causes errors and what fixes the errors, you're not going to get any better. So I went to the tutorial. C++ is a compiled language. Python is an interpreted language, and the compiled languages are typically a little bit faster than an interpreter. And so I'm going to skip right over the thing about compilers and get right into the stuff. And it has uh, the basics of everything that you need to know, really. And then with a lot of other things, it's not going to have like a how to write your own video game uh, guide with your implementations in mind. You have to be creative and code things yourself, make your own programs. So right here, the best way to learn a program, the best way to learn a programming language is by writing programs. So even this website seems to agree with me. That's funny. Typically, though, the first program beginners write is called a Hello World, which simply prints Hello World to your computer screen. Although it is very simple, it contains all the fundamental components that C++ programs have. So this right here is it's saying that this is a message. Do not run this as code. This is for humans to read. And it says my first program in C++, and then it's including IOStream. You're going to want that at the top of everything. And then usually you're going to want to do include using namespace std. So you don't have to write std : before everything. But, and so before you jump into writing up a bunch of classes in different files and then using those files, like importing those files to use with your main function over here, before you get complicated, keep it simple. And this is very, very simple right here. Just print hello world within a main function. So yeah, that's another thing. The brackets don't have to be like that. That's just programmers typically do that to clean things up a bit, but it can look like this, which some people think looks cleaner. But you'll see most things that you write into a program are going to require a lot more than just a simple cout saying something. Now, this is a second implementation where it says a second thing. Now, note that it says hello world, and on a different line it says I'm a C++ program. And intuitively, when you're writing something like this, you run it, and then bing, they're on the same line. And you're like, well, why is that? I wrote them on two separate lines. If I wanted them on the same line, I would have put them just in the same quotation marks. What's going on here? You have to tell the program to end the line, or it'll keep rolling till yeah, it'll keep rolling. You have to tell it to end the line. um, I was gonna write something up, but honestly, the the documentation that the programmers that wrote these things have is far better than anything that one person who uses it somewhat is going to be able to explain to you. It really, this is the best way to go about doing things. So let me keep where I'm at here, and I'm going to show you real quickly. Like, there's nothing to do with C++, but just to show you, I Google machines SciPy docs. SciPy is a library used in Python, as you can see here. Now I'm going to the SciPy docs. Getting started. User guide. Developer guide. I'm gonna go to the user guide. And just like the C++ one when we were on, if you want to know how to do anything at all, drum roll please. Read the documentation. And this will show you how to do anything you want to do. Everything that they made SciPy for. They have an example, and then you can run this example and then see, okay, what do I need to do to implement what I need to do on my own data with these same parameters. Well, not the same parameters, but the same setup. Let's say I want to do a Fourier transform. I want to learn how to do that. Fourier transforms are for waves, by the way, and they're incredibly important. It might be one of the single most important algorithms that we have, the fast Fourier transform. Anyway, back to C++. I just wanted to show you that it's not uncommon if you really want to learn something will you go away? Thank you. All right. It was hiding my ability to get back here. So if you want to write a comment on a single line, you do it with 2 backslashes like that. Or I guess that's a normal slash. And then if you want to do a block comment, which means it will go more than one line, this is a bad example of what a block comment is. It should at least have spaced down to the second line to show you that that's what the purpose of it is, but anyway. It does, see? Right here. Ta-da! And then it's just your same printing of hello, I'm a program. I'm a program. There are a bunch of different types of data, a bunch of different variables, data types, and things that you can create. There are integers, they're numbers, whole numbers. There are floats, which are not whole numbers. They are numbers point something. There are long floats, which would support bits of well, not pi continues on forever, but it'll show you quite a bit of pi with a long float. And there are character variables that you can create that are just a single letter, or you can have a single number be a character as well. You can have strings, which can be letters and numbers and other things in any ASCII Unicode approved thing can be in a string, I think. And they can be in any combination. You can group them all together into arrays or vectors or matrices. And they're usually all made of the same data type most of the time. I think there's ways. No, I think it's all of the time. They pretty much, if you're going to group things together, they need to be all of the birds of a feather. This is creating, I'm not sure why it's not saying int. Now, to me, if if I did write something up, I would have gone int A, int B, and then done your A equals 5 and A equals B. You can do it all in the same line. You can go int A equals 5. I don't think you can just go A equals 5 in C++. I think you have to tell it that you're about to give it an integer variable. If you want it to, well, I guess it'll add strings and it'll add characters too. But this is a simple program here that takes 2 variables and adds them together, or takes A equals A plus 1. Oh, that's just making it 6, and 6 plus 2 is 8. Or 6 minus 2 is 4. Need to look at what I'm looking at. These are keywords. You can't name anything this, or this, or this, or this, or this, or this, or any of the other words in this list. because they are reserved keywords that are already functions of C++. Can't name anything those things. I think you can change the capital, make some of the letters capital, and then you can name it that thing. But it can't be how it is. These are keywords, and all of them do something. Like said, for instance, we have floats, we have characters, char, we have integers, int, we have longs, long, we have shorts, short, string. Where's string at? String. I want string. str. String. I don't see string in here. That's weird. Anyway, you can't. All of these are functions of C++. Moving on. They're character types, numerical integer types, floating point types, and Boolean types. Boolean types are basically how your computer operates in its entirety. There are little zeros and ones that are connected to a little micro circuit. And that is a Boolean operator, a yes or a no, true or a false, on or off. Is a Boolean operator. This is a good chart. It tells you what you need to know. Another chart. It's good to know how much size something is taking in the C++ field. Transistor. Little transistor was the word I was looking for. I think. Something like that. Maybe I should be reading all of this. So here's, you're creating an integer variable A. They're not declaring it though, or they're declaring it, but they're not initializing it with any value as of yet. Same thing, they're creating a float variable named my number. Now you can declare multiple things of the same type on the same line, just like so, or you can do it like that, where you write int 3 times. This seems more efficient, so I usually do go with that, given the chance, the opportunity. When I'm trying to explain things to people, though, I do write it out like that, even though it is kind of nonsensical when it will allow you to do it in a more streamlined fashion. Okay, so we have a little bit more complicated main function. This is, again, should return 4. It's declaring A and B, just like I had said, and it's declaring the result. And it has cout result, and it will print, it should print 4. Let's open this and run it. That was really slow for it's usually a lot faster. It's probably just because I'm doing a Zoom conference. Shout out to Zoom. Doing all my presentations via that. So now, let's say I want to get really fancy. I'm gonna get fancy now. All right? All right. We're gonna do something here. Get rid of that. All right, we're gonna do something fancy. Say so. You can do these on the same line, by the way. I'm just doing this like I said. When I do a presentation of some kind, I like to be clear about what I'm doing. I'm asking for A, and I'm asking for B. Yeah. Let's go. Give me a number. Whole integer, please. Sorry, not talking. I'm doing here in a second. So I switched things around a bit. Now what it's gonna do, hopefully, as long as I remember, if I remember what I'm doing correctly. A is 5 and B are 2. It's already been initialized. I'm changing that though, and I'm asking for new numbers. And I did away with the subtracting. Now we're multiplying the two numbers together, and now it's gonna print out the result of two numbers. So run this, it'll say, give me a number. It doesn't like the endl situation. So what I do is this. I think will solve the problem. No, it doesn't like that either. Well, we'll just deal with this for now. I was pretty sure that's how you did that, though. That's how you would end a line. But all right, so 103. And oh, it already did it, so I didn't even need to bother with it. Okay. And 7. And there you are. and it was pretty fast even. So now let me try something else. Now I've made a new thing. And it's going to, huh. Okay, I see, I see, I see. I'm pretty sure that'll roll. That'll fly. Yeah, yeah, it's gonna let this fly. That's how you do that. I I was Pythoned out. You can't do the double multiplier operator in order to raise to a power. You type pow and then put it in parentheses with a comma separating which you're trying to raise to what. So I want 2 to the 16th. Excellent. Excellent, excellent. Okay, let's switch it up a little bit. Let's do something a little more fancy. Now, what I did was change it so that instead of getting just the plain result, we're printing out the square root of the result of whatever the power is, ends up being whatever the exponentiation ends up totaling to, times the logarithmic result. So I am raising 3 to the 17th. Wow, and it did it really fast too. And that is not just 3 to the 17th. That is, and just to show you that, I will go see out result. Let's do it again. All right, so let's go 12 to the 9th. Whew, too big. So too big. Again. Let's go 2 to the 10th. Huh. I wonder why it's not writing both of them like I wanted, like I was telling it to. So let me just do away with, we got, that has to be the square root times the log of the result because it should have gave us a solid. But you have your proof though anyway now. But I wonder why it didn't do it. It's very strange. There we go. Anyway, back to the website. All of these are valid techniques for declaring what the thing is. And that's what this is saying up here. All these will initialize the variable. Uniform initialization, co-constructor initialization. That's declaring a string variable called myString, and we're saying myString is this is a string, and then this is printing myString, which says this is a string. This is the initial string content. This is a different string content. Hmm. Signed and unsigned longs. But I recommend if you really want to learn, I mean, I could be reading all these things for you, but I was trying to pick out the things that are. All right, so Boolean operators he's creating here. One called foo is true, and the bool called bar is false. And he's creating an integer pointer, p, a constant double pi, and a constant character tab. Oh, that's a neat one. Finds the area of a circle, or the diameter. And if you go edit and run on cpp.sh in the corner there, it'll bring you to where we were just at a second ago, where I was just running that. Ah! No, go away. Why does that go even pop up? There. This is the C++ shell, and that's where that brings you, and with this code that's written here even. Operators. Hmm. Everything is here is as you should be familiar with. That's multiplication, division, subtraction, and addition. And this is the modulo operator. If you know about modular arithmetic, it's pretty basic. Like, uh, we, all of our arithmetic is in a base 10. So it'll return the normal numbers. But if you go to, say, base 4 after, so 5, base 4 is 1, it returns just the remainder after it divides whatever your modulus is into it. That's modular arithmetic. you can do plus equals is the same as y plus x. A little shorter than writing out y equals y plus x. Same thing. These are compound operators. You got to make sure to do them how they read in here, though. Sometimes you get some weird things returned back to you, and you're like, why did that happen? Incrementing and decrementing. You should know what these do, especially because for loops and while loops and if loops, those things are pretty constituent parts to being able to code with any level of proficiency. Um, so this, I've always found that these things are pretty close to the same thing, but one adds it beforehand and one adds it afterward, and I think one uh this is the one I usually use, and it always lines up right with what I set my I counter to, like for I less than the length of the array or whatever you're trying to do. Array dot length, and that always seems to line up with the count just fine. Where this one, I think, adds another x yet after the fact. Some I I've never actually wrote a code with incrementing it with it on the other side. I've always gone plus plus I. Oh, this is saying they're mathematically equivalent. They do indeed the same thing. Oh, no, they do not do the same thing. It adds one for some reason to the y value. Hmm. Maybe somebody better should explain that. I'm pretty good at figuring stuff out from reading things, but at the same time, I may not be the best person to go through all of this. I'm trying to just find the good big points, and then hopefully you'll find it within yourself to come to this website and actually read through this documentation. It will tell you what is going on. This is something we should probably be doing here. The logical operators. This stuff is important actually. Not equal to. Actually like mathematically equal to. The equal sign, a single one, is an assignment operator, and it doesn't actually mean mathematical equivalence, whereas this does. You should really avoid using this unless you mean it. Unless you really mean for it to evaluate if something is. If it is this number, then yes. The pipes and the ands and ors. Bitwise operators. That is a good one here. That's a good visual. So yeah, if you really are serious about learning C++ and want to do the deep dive, I am going to do a part two where I keep going through some of this. I might actually write something up myself, like just a sample code of a kind, and then I'll keep switching it up in the presentation to show you the different things that you can do and what the output would be when you do that. But I think this is a good part one for now. So thank you guys for watching. If you like, subscribe. If you would like to become a part of the Mankind in Training community, I'm doing an Ask Me Anything episode. I have a couple of questions in, but I need more than a couple questions. I need like a full episode's worth of questions. So once I do have a full episode's worth of questions, I will be answering anybody who has sent me ask me anything questions so far. If you'd like to support me on Patreon, I do have Patreon account, and I do have a GoFundMe account also because the school has cut my classes back to one. I only have one class at a time now until February or something like that. So I'm trying to raise some money so I can actually get back to taking three at a time like I'm supposed to be. But thank you guys for watching. I am going to bounce. If you've liked, enjoyed, subscribe, and I will be back later tonight. I'm going to do another theom theoretical math example in SymPy. So I'll catch you there.